Hi, how are you doing? This is IBM-i By Doing. Welcome to IBM-i By Doing, a series of video sessions in which we do hands-on projects programming the IBM-i Midrange computer. I'm Madhu Vasudevan with over 20 years of IBM-i work experience at your service. The target audience is newbie programmers who want to learn RPG4 or RPG ILE on IBM-i. We will mount our RPG bikes right on top of the subfile hill and slide down the valley of data file processing in RPG4 ILE. Just follow along. Working along with me, you will be able to do this. Early in this series, we will tackle the fabled RPG subfile, and we will create every possible variation of the subfile. We will create physical files, logical files, display files, printer files, and of course the RPG ILE programs to handle all these files. We will create some information display screens, some data entry screens, and generate some reports. Welcome to this session on RPG4 ILE programming. In this virtual life on the cloud, you are a crossing guard on the Hogsmeade Railroad Station. Besides escorting newbie schoolers to the Hogwarts School of Magic, you have to build the computer interface for Muggle parents who want the train's departure information at hogwarts.com. In this magical session, we will cast a spell to create a physical file to hold train's information, create a display file with a subfile for keying in the train's information to enable heads-down data entry, create a data entry subfile program to enter data into the train's information database file, run the data entry program to populate the physical file with the train's information, query the train's physical file to view the entered records. Our data entry subfile program will allow users to input multiple train records in one screen. This allows for the so-called heads-down data entry method of keying in data, record after record, without pausing to look up. After entering a screen full of data records, user will press enter to save the records. The program will save only valid records to the physical file. Invalid records will be brought up for review. This process can be continued as long as user wants. Finally, F3 may be pressed to quit the data entry program and end the data entry session. The newly added records may be viewed by querying the physical file. This subfile query program we will write later in another hands-on video. For now, we will run the query command to view the data records added to the train's physical file. To keep us motivated to produce more of such high-quality free content, please subscribe to this channel. Hit the like button below, leave a comment or two, and share this video with your colleagues, friends, and other IBM-i enthusiasts. Hit the bell icon below to actively follow along with the rest of our series. Having created a display file with a subfile for keying in the train's information, let's create a data entry subfile program. We need a separate source physical file to hold RPGLE program source code as members. Now we will create the source physical file called QRPGLE src. Key in the command crt srcpf and take an F4. Key in the file name QRPGLE src. Tab over. Although library defaults to my current library, I will ensure it gets created in my second library by specifying it. Tab over. I will increase the length of the file to 112. No need of any members, so tab over. For description, key in RPGLE source file and hit enter. Note the successful file creation message in the bottom. Key in the command dsplib, your project library, and hit enter. Note the addition of the object in your project library. Note that it is a file object of attribute pf. Press F3 to return to main menu. So let's write the RPG4 code to enable data entry via subfile into our train's physical file. We can use the source entry utility SEU as our source code editor. To launch SEU, key in the command strpdm and hit enter. Take option 3 to work with source code members. Ensure file name is QRPGLE RPGLE src, and library is your project library, and hit enter. Now you are inside the Program Development Manager PDM. Key in an F6 to create our first RPGLE source member. Key in the member name, train, add, update, program. Train ADUPG. Source type needs to be RPGLE. Field exit. To clear rest of the input field and move cursor to the next input field, we do a field exit. In my keyboard, it's the long plus key. For description, key in add/update db file train set with subfile and hit enter. Now you're inside SEU. Note the column specification ruler on top. Move cursor to the first input row under column spec K of keywords and key in /free. Move cursor to the last input row under column spec K and key in /end-free and hit enter. One more time. Press F3 to exit SEU. Against change create member, press Y and hit enter. PDM says that you have created a source code member called train-up-adg in the source physical file QRPGLE src in your project library. We have merely created an almost empty program source code member in the source physical file QRPGLE src. We will key in the RPG4 program in the modern free format using a more modern editor than SEU. Press F3 a few times to return to the main menu. Minimize the IBMi client emulator window. We will use Visual Studio Code to write and compile our RPG4 subfile program. Again, Visual Studio Code is a freely downloadable application. The link to download Visual Studio Code is in this video's description. After downloading and installing the Visual Studio Code application, launch Visual Studio Code. Make it full screen. In the left bar, click on the extensions icon. In the search bar, key in code for IBM -i and hit enter. Click on the plugin code for IBMi and install this plugin. After installing the plugin, close the plugin window and click on the IBMi icon. Click on the blue Connect to an IBMi bar and fill out the login form. For connection name, key in pub 400. For host or IP address, key in www.pub400.com. For port, key in 42s. Key in your username and your password. Check the Save Password option and click on Connect. You don't need to configure anything right away. Just accept the defaults. Close the message pop-ups in the bottom right. In the User Library List pane, click on the Add to Library List option. Key in your project library name and hit enter. Using up arrow clicks, move your library all the way up. Under Object Browser, click on Create New Filter. In the New Filter form, key in your project library name. Accept all defaults and click on Save Settings. Click on the arrow next to the filter to expand it. Voila! Under QRPGLE src, you can see your program source code member. Click on the member Train Add UPG to open it in Visual Studio Code for editing, and Legacy RPG has reinvented itself to meet the challenges of the modern age. There are no column restrictions while coding in free format RPG4. However, to be able to view the code without error highlighting in the green screen SEU, we will keep all code beyond column 8. The header specifications are now called control options. So let's key in some control options. begin with the copyright. This is optional. End every line with a semicolon. Another optional control option, just a small description. We cannot code beyond column number 80, so we'll code from 8 to 80. The date format, we need it to be in *USA format, which is month, day, year, 4-digit year. Unfortunately, this plugin, as of now, does not offer F4 prompting, but it is free format. No column restrictions. Control S to save whatever we have keyed in. Next, let us write the file specifications, which go by the name DCL-F for declare file spec. Physical file train set is a disk file which is externally described. Usage in this program is for update and output, and it is a keyed file, semicolon. Next file spec, DCL-F, display file, train UPADF. Train update add display file is a workstation file which is also externally described. This display file has a subfile, SFILE. The subfile record format is SFL tran, and the record number field is RRN, the field which holds the active record number of the subfile at any time. Hit enter, tab over. Remember, this is free spec. Continuing the keywords for the declaration of the display file, IND, DS, indicators, a data structure called indicators, and semicolon. Let's do the dspec next. Declare DS for declare data structure. Uppercase, lowercase doesn't matter. Declare data structure called indicators, which has two types of indicators. Response indicators, which are just two. Exit, a field of type indicator beginning at position 3 in the data structure, semicolon. Next response indicator, we'll call it cancel, which is also a field of type indicator beginning at position 12 in the indicators data structure, close bracket, semicolon. Next, we'll describe the conditioning indicators. Mainly they are our subfile control indicators. SFL clear, a field of type indicator beginning at position 50, because that is the indicator number we have assigned to this control keyword, SFL CLR. SFL DSP is a field of type indicator at position 51, close bracket, semicolon. And we have a train not updated indicator beginning at position 91. Having declared the fields in our indicator data structure, we just end the data structure definition, end DS, semicolon, Control S to save. We will need some constants, so let's declare the constants next. DCL-C for declare constant, rex in page, number of records in one subfile page. Our subfile page size was 15, which we declared in our display file. Next, constant DCL-C maximum platform number, constant which we will restrict to 5 platforms. Next constant, declare constant for maximum ticket price, max ticket. Let's restrict ticket prices to 500 Kanats. We'll need one standalone field indicator, DCL-S, for declare standalone field variable, call it valid SFL record, which is a field of type indicator, semicolon. And we are done with the declarations. Control S to save. Let's begin coding. The CSpec or the program lines, / for comments. First initialize the subfile, execute subroutine, clear subfile, semicolon. Next, execute subroutine, load subfile, semicolon. Next, write the footer record from the display file, semicolon. Set off the indicator for train not updated. This is part of the validation logic. You will see. Set this indicator off. The field instruct we will initialize with the message enter valid records to add / update. Don't forget the semicolon after every line. Then we start the loop. So let's say loop until F3 or F12 is pressed. we'll write a do until loop. Do until indicator exit is on or indicator cancel is on, semicolon. Indent X format, meaning write and then read, subfile control record, CTL tran. If not exit, exit key not pressed, F3 not pressed, and not cancel, meaning F12 not pressed, execute subroutine update db. End this end if and end the end do. End the do until, semicolon, and we are done. Set on the last record indicator and return. Ctrl S to save the code. Now let's write the subroutines one by one. First up, clear subfile. Comment clear subfile and set RRN, active record number of subfile, to 0. Copy the commented star line. Begin subroutine, clear SFL, and it needs an end subroutine. Comment name of the subroutine that is ending, clear SFL, and don't forget the semicolon. SFL DSP, turn it off. The subfile display has to be turned off, and SFL clear, subfile clear keyword needs to be turned on, and the subfile control record format needs to be written, CTL tran. That's how we clear the subfile. Now the SFL clear indicator needs to be set off, and the active subfile record number, RRN, set it to 0, semicolon, and we are done with clear subfile subroutine. Ctrl S to save the code member. Next up, let's code the load subfile subroutine. Copy these first 4 lines, paste it below. Copy the end subroutine line, paste it below. Comment needs to be changed to load subfile with blank records. The name of the subroutine is load SFL. Copy it, Ctrl C, paste it so we know which subroutine is ending here. Start the do while loop. Do while the active record number of the subfile is less than recs in page. This do while needs an end do, semicolon. Inside the do while loop, execute the subroutine to move blanks to subfile record, semicolon. Enter, increment the relative record number or the active record number of the subfile by 1. Write the subfile record, SFL tran, semicolon. After the end do, set the display SFL DSP, the display flag, to if we have any active records. That's the conventional way of setting the subfile display flag. RRN should be greater than 0, then we have something to display in the subfile. That's it for load subfile. Ctrl S to save it. Next we code the update DB subroutine. This subroutine is the heart of this program. It's a little long, but hopefully straightforward. Copy the first 4 lines from the previous subroutine, paste it below. Copy the last 2 lines from the previous subroutine, paste it below begin subroutine. Change the subroutine name to update DB. Case doesn't matter, but we'll just keep it reader friendly. The comment is also a little long, but hopefully straightforward. Read, change the subfile record and add update corresponding database record. Within the subroutine, first thing, the flag train not updated, set off. Default instruction to the user is enter more records to add or update, semicolon. SFL display keyword indicator needs to be set off. Read the changed subfile record, SFL tran, and do while not built-in function percentage end of file display subfile name train UPADF. This is where Visual Studio Code outperforms the SEU. This do while needs an end do, semicolon. Feel free to insert comments wherever you feel required. Execute subroutine, validate the subfile record. Validate SFL is a subroutine we need to code further on. And after performing the validation subroutine, we check if valid subfile record indicator or flag is on. This if needs an end if. Thank you Visual Studio Code for filling up for me. If the subfile record was valid, we chain to the train set physical file using the subfile column or field S_traino, end key, semicolon. After chaining to the train number, execute the subroutine move to DB, in which we move the values from subfile record to database record fields. Enter. If the chain was successful, %found built-in function, the file name. Built-in functions always need the file name, not the record format name. So %found physical file train set, semicolon. This if needs an end if, semicolon. If we found a corresponding record in the database file, we update the database file, record format, trnrec, else. Else if we did not find the corresponding record with the same train number in the physical file, we write a new record. Write record format into the physical file, trnrec, semicolon. After either updating or adding to the physical file, we blank out the subfile record. So execute subroutine to move blanks to the subfile record. Move blanks to SFL is another subroutine we need to code further on, and having blanked out the subfile record, update the subfile record, SFL tran, semicolon. Else, if the subfile record input by the user was not valid, turn on the flag train not updated equals *on, and we update the instruction instruct equals the message check invalid or blank records, semicolon. Then read the next changed subfile record from record format SFL tran, semicolon, and the loop continues. After all changes have been read, set on the subfile display SFL DSP equals *on, semicolon. End of subroutine, Ctrl S to save it. That was a little bit long subroutine, so watch out for bugs. Next, let's code the validate subfile record subroutine. Copy the first 4 lines from the previous subroutine, paste it below the previous subroutine. Copy the last 2 lines from the previous subroutine, paste it below. Change the subroutine name to validate SFL, copy it, paste it in the comment so we know which subroutine ends here. The comment needs to be changed. Validate subfile record fields. If the train number equals blanks, enter couple tabs, or s_center equals *blanks, or built-in function %check or blank, or 1 2 3 4 5 6 7 valid characters within weekdays. If there are any invalid characters other than space and 1 to 7, all characters are considered invalid. If they exist in weekdays, or the platform number PLTF is less than 1, or platform number is more than our constant max platform number, or the start time STR time is a number less than 0, or the start time is a number greater than military time 23 hours 59 minutes, or the ticket fare input is less than 1 Canuts, or the ticket fare input is more than our constant max ticket, or the engineer name s_engineer was left out, *blanks. In all of these cases, end of the if statement, get the indentation correct, 2 spaces. Our valid SFL rec field or indicator or flag should be offed, *off. Else, the valid SFL rec indicator should be on. It's a valid rec. End the if with the end if, semicolon. That is our validate subfile record field, a simple first level validation. Ctrl S to save the subroutine and the code. I can see that I left out an OR here. Start time less than 0, or start time greater than 2359 hours. Ctrl S again. We need to code 2 more simple subroutines, 2 simple move subroutines, subroutine to move blanks to SFL and move the values to database. Having created a display file with a subfile for keying in the train's information, let's create a data entry subfile program. To keep us motivated to produce more of such high-quality free content, please subscribe to this channel. Hit the like button below, leave a comment or 2, and share this video with your colleagues, friends, and other IBMi enthusiasts. Hit the bell icon below to actively follow along with the rest of our series.